Right, on to topic 3.4, which is our last initial type of reduction before we summarize. We will move on to some different reductions, but these are all kind of within one idea. So now we're looking at 360 minus theta, and again we're going to get better and better at this because it's exactly the same concept. Right, how do we create 360 minus theta? Well, if I reflected this angle of theta directly over the x-axis, I would get an angle of theta there. I would get P dashed, and as you will see, the x value will remain constant because I've reflected over the x-axis, so my x value is still in the same place. However, my y value will change sign, so that's now negative b, and my r is still r. So what angle have we created? If we go all the way around from the x-axis anti-clockwise to this line, that's the angle we've created, and that will be 360 degrees if you went all the way around, but you didn't go all the way around. We didn't go through this value of theta, and so it's 360 degrees, take away theta. So what we're going to do, exactly like we've done before, we're going to look at sine, cos and tan, and we should start being able to predict what we're going to see. Okay, what have we seen? We know that sine of theta is b over r, we know that cos of theta is a over r, and we know tan of theta is b over a. So now let's look at 360 minus theta. So if we look at sine of this angle of 360 minus theta, sine is y over r, so this would be negative b over r. Cos is x over r, which you'll notice remains exactly the same. And tan is y over x. So again, let's look for these patterns. We'll notice that sine of theta, which is b over r, I've still got b over r, except I'm now talking about the negative cousin. Now, that's entirely predictable because we are in the fourth quadrant, and our quadrants are all stations to Cape Town. So this is a quadrant where cos is now the only ratio that's positive. So it makes complete sense that sine of an angle in this quadrant will be the negative cousin. So the first conclusion that I can make is around the value of sine of 180 minus theta. Sorry, sine of 360 minus theta. So sine of 360 minus theta is the same thing as sine theta, except it's the negative cousin. Right, let's go back and have a look at the relationship in cos. Cos of 360 minus theta is a over r, and so is the cos of theta, making complete sense because we're working in quadrant 4. So our conclusion is that cos of 360 minus theta is always equal to the positive version of cos theta. And our last relationship exists between tan of theta, which is b over a, and tan of 360, which is the negative version. So, quite predictably, our conclusion is that tan of 360 minus theta has exactly the same ratio as tan theta, except it's the negative cousin. So again, nothing is changing in terms of the ratio, but you're just having to decide based on the quadrant whether it's the negative cousin or the positive cousin. Right, let's have some quick look at examples like we have been doing. So, without a calculator, which means, we've seen this before, can we rewrite this angle, for example, in A of 330? Can we then reduce it and then use our special angles to actually get a number answer? So, first question, can you rewrite this as 360 minus an angle? I could do 180 plus, I could do 180 minus, I've learned those as well, but this is 330. And if we know our Cartesian plane, we all know that 330 is all the way around into quadrant 4. And this angle to complete the 360 would be 30. Therefore, I can rewrite it. I can rewrite 330 as 360 degrees minus 30. Now, I know that that simplifies to tan of 30. That reduces to tan of 30. So I've rewritten 330, and now this step is my reduction. I'm saying I know that tan of 360 minus 30 is the same thing as tan 30, except it's the negative version of tan of 30. Now, if you use your special angles, you'll probably tell me that's negative 1 over root 3. If you use your calculator, you will say that it's negative root 3 over 3. Either one of those is fine. It really isn't a problem. Right, let's start the same concept again. Can you rewrite 315 as 360 minus an angle? Hopefully a special angle, because then I know how to work it out. And I can, because 315 is the same as 360 minus 45 degrees. And this is where I do my reduction, because I know that cos of 360 minus an angle is exactly the same thing as cos of that angle. And I know, because I'm working in quadrant 4, that cos is positive in quadrant 4. And so that's why I know it's the positive cousin of cos 45. Now, cos 45 again is a special angle. You're welcome to use your calculator, but eventually we should know that cos of 45 is root 2 over 2. And our last example is sine of 300. Exactly the same concept. Can I rewrite 300 as 360 degrees minus an angle? And I can. 300 degrees is equal to 360 minus 60. Now I'm going to do my reduction. I know this reduces to exactly the same thing as sine of 60 because of the symmetry. However, it's the negative version of sine of 60 because this is sine, and in quadrant 4 sine is negative. Now either my calculator or my special angles will tell me that sine of 60 is root 3 over 2. So this is the negative version of root 3 over 2. So this wraps up the first 3 reduction rules. We are going to do one more, but these are all kind of one family of reduction. So our next video is going to summarize this. How do we remember these kind of rules? And then we can actually start to practice, which is cool. Well done, everyone.